So our setup is that Carl is the only source of employment for individuals on the island. So here we have the production function. So this is our production function. And this wage here, this is our labor supply. And he's going to charge $1 per output. So we think of the profit maximization problem that Carl's trying to solve is he's trying to maximize profits, which is price times the production function minus the input costs, which is wage times labor. There's only one input in this scenario. And so we can put these in. So price is 1, so it's just going to be 1 times the production function, which is 10L minus 1 over 80L squared, minus wage is defined as 1 over 80 times L. Now to maximize profits, we're going to take the derivative with respect to profits with respect to labor. So we'll get 10 minus 2 over 80 L minus 2 over 80 L equals 0. Now one thing to note is this is the marginal revenue product of labor, and this here is the marginal cost of labor. Okay, so we continue solving for this. We'll get 10 is equal to 4 over 80 times L. And therefore, L star as a monopsonist is equal to 200. Now, the wage, we take that 200 is 1 over 80, and that's a monopsonist, times 200, and this wage is 200 divided by 80, which is $2.50. So this is the example of the monopsony. Now let's suppose that for Carl, instead of being the only provider of work on the island, let's suppose that he's now operating in perfect competition. Well, if that's the case, in perfect competition, we're going to take labor supply and set it equal to labor demand. So labor supply is given from 1 over 80 times L, and our labor demand is our marginal revenue product of labor, which is 10 minus 1 over 40 times L. And now we're going to solve for L. So we get 1 over 80 plus 2 over 80. So I'm just going to convert the 1 over 40 to the same denominator. There should be an L there, an L here, plus 10. Therefore, L star for perfect competition is 10 times 80 over 3, which is equal to 266.67. So that's the labor they hire in perfect competition. The wage in perfect competition is equal to 1 over 80 times L star. And so this is going to be $3.33. So there we see, we can compare monopsony and perfect competition. That in monopsony, they're going to hire fewer workers, 200 compared to 266, and pay a lower wage, 250 compared to $3.33. And this because they have market power. Now let's look to see what happens when we have a minimum wage. So let's come over here, and policymakers are going to set a minimum wage. So let's suppose that they set minimum wage star for min wage is equal to $4 per hour. Well, if this is the case, then when wage equals marginal revenue product of labor, we can simply set 4 is equal to 10 minus 140 L. And then we solve for L. So we'll get 140 L is equal to 6. L star in our minimum wage example is equal to 240. And our wage star is equal to 4. And so now we compare and contrast between the three different examples. So if we start in a monopsony, minimum wage will actually increase the number of workers and increase the wage compared to a monopsony. Now, if we compare it to perfect competition, it will actually increase the wage, which is the goal, but it will actually decrease the number of workers. And so that's where we see a minimum wage can have a different impact compared to a monopsony as compared to perfect competition.